Hey guys, Wix100 here, back with another C# tutorial, and today I'm going to show you how to do operator overloading. So I'm going to be working in the same number solution that I was working in for the conversion tutorial from last week. So if you haven't watched that video, go watch it. Or you could just start off from here. It's not too hard to figure out what was going on in the previous one. I just created a private field of underscore value and a public property of value and a constructor for number. Number is a struct that I created. And then I went through different ways to convert to and from the number struct. This time, I will demonstrate operator overloading. So that means that by the end of the tutorial, we will be able to do number A, number B, and then number C equals A plus B. We will also be able to do multiply, divide, subtract, modulus, increment, decrement, negate, all those different operators. So let's start with the unary operators. So public static number operator plus number n, and we will just return new number with the value of, actually, we don't even need to do that. We can just return n. Not entirely sure why this exists, but basically, if you have the positive of a value, it's the same value. We can do the same thing, except with negation, and this will be new number minus n dot value. So we're just using the negation operator for the value, the double value of n, and then putting that into a new number. Alternatively, because we have this set up, we can just cast the value to a number. Then we're going to do increment and decrement. So that's 2 pluses and 2 minuses. And just like before, we're going to use the predefined increment and decrement for value. If you're doing a more complex struct that's not just simply storing a double value, you can do other things with it. Like if you're doing a date, you can make it so that the increment increments the day or the minute or the hour or the second, or increments all of them or none of them. You can do all kinds of things. You don't even have to make it actually increment something. You could overload the increment operator so that it just sets it to 0. I don't know why you would want to do it. It might be confusing for anyone that would be using the custom data type that you defined, but you could technically do that. Because all this really is a function that is returning a number, or it's returning the custom type that you're working with. So now that we got the unaries done, let's do the binary operators. So public static number operator, if I can, yeah. And let's do addition first. And so we want number A and number B. And we are going to cast the result to a number because we're outputting a number. And we want to do A dot value plus B dot value. So, and this is an equal sign. I want a plus sign. So, we're just adding the values and casting it to number. And if you aren't seeing a pattern, shortly you will, hopefully. So I pasted this in 4 more times. If you can't tell, there are 4 more arithmetic operators we're going to be using. Subtract, multiply, divide, and modulus. And so they're going to be the same thing. For subtract, we're going to subtract. For multiply, we multiply. For divide, we divide. And modulus, we modulus. It's that simple. You just need to create a function that starts off like this and put whatever you want in the body that returns the type that you're working with. So if we go here, we can do, notice this isn't errored out anymore. And if we do a dot value plus b dot value equals c dot value, and we run this, it says it says pi plus 3 equals 6.14159 blah blah blah. If we change this to multiply and run it, then it should say 9 point something as the result. 9.4247779605. We can do, let's change this from pi and do 10 and make this modulus. If you don't know, modulus is you divide the first number by the second number and then output the remainder. So 10 modulus 3 should have an output of 1 because 3 goes into 10 3 times, but that would be 9, and 10 minus 9 is 1. And so we get the result of 1. So our operators are working fine, as you can see. We can also do negative, and let's make this 3. And so negative 3 times 3 should be negative 9. There you go. So all our operators seem to be working. I know I didn't test them all, but they should be the same concept. That's how you make arithmetic operators. I will also eventually go over how to make logical operators. Logical operators are like equals, not equals, less than, greater than, those types of things. So, hope you guys enjoyed. Hit the like button down below. Questions, comments, and concerns in the comment section. Any relevant links will be in the description. Till next time, bye!